Chapter 22, Example 3. A coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups. Is there evidence that the machine is shortchanging customers? So since we want evidence here, we are using a hypothesis test. I have the data presented for you here in the problem, and it's available on the handhelds. So our null hypothesis is that the population mean, mu, equals 10 ounces of coffee. So we're filling the cups to 10 ounces. The alternative is that the population mean, the true population mean, is actually less than 10 ounces. So we're actually filling all of the cups of coffee with less than 10 ounces. As usual, we want to state the conditions before we proceed. I have a random sample of 20 cups of coffee. And 20 cups are fewer than 10% of all cups of coffee the machine makes. So now we look at the normal probability plot, and if you look, it fits a line pretty well. It's pretty straight. Doesn't seem to be any points very far from the line. Everything looks really good. So a normal probability plot for the distribution of the amount of coffee in each cup is fairly linear with all the data close to the line. The conditions are met. I will use a student's t-model for a one sample t-test. Now this time we're going to do all the calculations in the calculator. There's no reason to do any of this by hand. It just saves us time and gets us to the main idea, which is interpreting what's going on. So we have all our data entered in. We've already looked at the normal probability plot, so we're going to do a calculator page. We're going to go to statistics. We will choose a statistical test, stat test number 7, and we're doing a t-test number 2. We have the data in the calculator, so we're going to use data. We have the data, so we're going to use that. Our population mean is 10. The list we had named coffee. And then our alternative. We're actually saying that the population mean is less than 10. So I'm going to change that so that mu is less than. And it does all the work for us. There we go. We have a t-score of negative 3.4901. Our p-value is 0.001225. And it gives us our mean as well, which is 0.9845. Provide the statistics that the calculator gave us, write that stuff down, so myself or on the AP exam, whoever's grading, can see that you have that data. Include degrees of freedom. We know there were 20 cups. Degrees of freedom is n-1, but it also will tell you that in the calculator printout. Our z-score was negative 3.49. And our p-value was 0.001225. This is much more accurate than we'll get from using a table. In a table, we'd have to go with about 0.0025. So my p-value of 0.001225 is very small. And I will reject the null hypothesis. There is sufficient evidence to suggest the machine is underfilling the coffee cups. Now, since we rejected it, let's get an idea of what the true amount is. We can do that by doing a confidence interval. So we'll go to Statistics, Confidence Intervals, a t-interval. And again, we're going to use that data that's already entered in. We just pick the list, coffee, hit OK, and everything's there for us. There's our lower, our upper, our x bar, which we already know, our margin of error, which is a good thing to go ahead and mention, the degrees of freedom. So a 95% confidence interval is 9.752 to 9.938. I am 95% confident that the true coffee cup fill amount of the machine is between 9.752 and 9.938 ounces.